Imagine waking up on a Monday morning
Yeah.
and finding out, 5 million people are just completely locked out of their bank accounts.
Right. All because a single line of code failed over the weekend.
Exactly. So today on our deep dive into Module 7.1, we are unpacking this massive kind of behind-the-scenes engineering miracle.
It really is a miracle, honestly.
It is. We're looking at how major enterprises modernize their 30-year-old COBOL and DB2 banking mainframes without causing a total systemic collapse.
And I mean, these systems are literally the backbone of global finance. They're incredibly reliable for heavy overnight batch processing, but, well, they are just so rigid.
Yeah.
They completely lack the agility for modern mobile apps or, API integrations. Plus, they cost an absolute fortune to maintain.
But you can't just flip a switch to upgrade them.
Yep.
A big bang overnight replacement risks absolute catastrophe.
It's a total disaster.
So, okay, let's unpack this. Replacing a monolithic core banking system overnight is, well, it's like trying to swap out the engine of a car while you're driving 70 miles per hour down the highway.
That is actually a great way to picture the risk. And, to solve this without crashing the car, software engineers borrow this brilliant concept from rainforest ecosystems.
Right, the Strangler Fig Pattern.
Exactly.
I love the name. It sounds a bit sinister. But how does a tree help us safely upgrade a banking mainframe?
Well, think about how a strangler fig actually grows in nature. A seed lands up in the canopy of an old established host tree.
Okay.
And as it grows, it drops these roots down the trunk to the ground, and it slowly engulfs the original host. Eventually, the old tree dies and rots away.
Wow, so the fig stands in its exact place.
Yeah, and software engineers do the exact same thing to old code.
Wait, so instead of stopping the car to swap the engine all at once, you were just growing new parts around the old ones.
Precisely. You incrementally extract specific business domains from the old mainframe and rebuild them as new cloud-native microservices.
Okay, so for those of us not coding every day, microservices are basically like tiny independent apps that do just one specific job, right? Like maybe updating a user's address.
Spot on. You put this intelligent API gateway in front of both systems to act as a traffic cop. So if you're a bank, you route just that one task.
The address updates.
Right. Customer address updates go to the new cloud system. Meanwhile, heavy mission-critical tasks, like processing wire transfers, they stay safely on the old mainframe.
Oh, I see.
What's fascinating here is that this allows engineering teams to deliver actual business value in a matter of weeks, instead of waiting years for some massive cutover project to finish.
So you literally strangle the old monolith piece by piece until it handles zero traffic.
Exactly, and then it can just be turned off.
Wait, I am trying to picture this in reality, though. If the old mainframe and the new microservice are running at the exact same time, aren't they going to have wildly conflicting data?
Well, that is the big challenge, yeah.
Because imagine you're at the grocery store. You swipe your debit card for $50, and that hits the old mainframe. But if you immediately pull out your phone and check your mobile app, which is on the new cloud system, isn't your app going to show the wrong balance?
It totally would if you were relying on traditional databases. But this is where Change Data Capture, or CDC, acts as the invisible bridge.
CDC. Right?
Yeah, making that dual system setup possible.
But how does it keep everything synced up without slowing the whole bank down to a crawl?
It uses event pipelines, usually running on tools like Apache Kafka, which are built to handle massive streams of data in real time.
Okay.
So when that $50 charge hits the legacy database, a CDC agent reads the transaction log the millisecond it happens and just streams that change over to the new microservice.
Wow. So by the time I have pulled my phone out of my pocket, the two systems are already perfectly matching.
Oh yeah, the sync usually happens in under 10 milliseconds. The beauty of that real-time shadowing is you aren't relying on heavy overnight batch syncs anymore.
Right, the data is instantly everywhere it needs to be.
Exactly.
All right, so CDC acts as the bridge preventing a data disaster. But data isn't the only risk here, right? How are they rolling out brand new code onto real users without risking a crash?
Yeah.
Because, new code always has bugs.
Oh, always. And this brings us to Canary releases.
Like the bird.
Yeah, think of the old canary in the coal mine used to detect dangerous gases. You use that same intelligent API gateway, so systems like Envoy or Kong, to slowly and safely shift live production traffic over to the new code.
Ah, so you don't just dump 100% of your users onto the new microservice on day one.
Never. You route just 1% of the traffic.
Yeah.
Automated monitoring then evaluates the error rates and CPU load.
Makes sense.
And if the new service is stable, the gateway automatically ramps it to 5%, then 10%, and eventually 100% over the course of a week.
But what if it's not stable? Say a bug slips through and, I don't know, crashes the new card authorization service at 2 a.m.?
Well, the gateway detects the failure instantly and automatically routes all traffic back to the legacy mainframe.
No way.
Yeah, the users never even notice a blip. If we connect this to the bigger picture, it guarantees zero operational downtime. The risk profile drops from extreme down to minimal.
So what does this all mean for you, the listener?
Yeah.
It means you get all the sleek, modern features on your banking app without ever knowing that these massive, heart-stopping system upgrades are happening behind the scenes.
It really is seamless modernization. You're replacing the underlying architecture piece by piece, spark plug by spark plug, without ever taking your foot off the gas.
And honestly, it makes you wonder, if this incremental zero-downtime Strangler strategy is the absolute safest way to replace rigid monolithic software, couldn't we apply this exact same philosophy to outdated human systems?
Ah, that's an interesting thought.
Right. Think about bloated corporate bureaucracies or massive government departments. Maybe we don't need a big bang revolution to fix them. Maybe we just need a Strangler Fig.